The third guideline I will cover is probably more relevant to Unreal in some ways, or more specifically blueprints, relative to some other programming languages or engines, just because blueprints have some overhead when executing compared to C++. I won't go into more details regarding that, but reducing overhead was one of the motivations for the third guideline, even though that use case might not be relevant to you. So third guideline is low atomization, flexible functionality. Design functionality to be minimally atomic, yet flexible enough to address a reasonably broad range of use cases. Let's start with an example that will showcase how this guideline can help us save on some overhead costs when executing functions in blueprints. Imagine you have a function, and because it is executed through blueprints, it has some performance overhead. For this functionality to work, you need 3 small functions. Since the functions are small, the overhead is similar cost to the function, so if you look at the same function executed in C++, they are 2 times less costly. To minimize the overhead, let's group the small functions into one big function. Now we only need to call this big function once and execute all the code inside it. If we compare it to C++ code now, the function still costs a bit more, but it is way less impactful. Depending on the functions and your setup, this abstraction won't be possible all the time, and you also have to be careful not to bloat or overgeneralize the function. This also can make it costly, since every time you call it, you have to do a bunch of checks and you're only executing a small fraction of the code. I want to go back to the description and emphasize these 2 words. The atomization and use cases for your functions will vary widely based on your project, your team, or any other factors, so think about what minimally and reasonably mean to you. Let's now go over a more functional example. Let's say you have a sequence of functions related to shooting in your game. You first check if the character can shoot, then you spawn the sound, spawn particles, and then the projectile. The cogs below the functions indicate a potential cost of the function. Now, if we assume the sequence is set in stone, we can merge them together in one big try-shoot function that will have inputs for spawn sound and spawn projectiles, and output to let us know if we successfully shot our weapon. We successfully decreased the overall execution cost of our shot sequence and generalized it a bit, so it can be used again for our different characters. Keep in mind that you can overgeneralize and make the function too costly and hard to use. It's important to figure out what is the appropriate function size for your project. The overreaching concept here is monolithic versus modular systems and where on that scale you want to be. Go too modular and performance will suffer. Modularity can also become less flexible and resilient to structural change because breaking down the modular system requires more effort. On the other side, creating one huge monolithic system can help with performance, but flexibility and teamwork can suffer, so this guideline tries to keep a balance and minimize downside of both development structures. That's it, thank you for watching.